Can you hear me now? Hey, what's up, everyone? Gonna have to add another. Had to add an audio source. Like, who said that? Weird. Okay. So, what am I working on? Well, I have this little module that I'm developing. I'm really excited. It's actually going to be a Kickstarter that I'm going to try to launch in like the next week or two. And I need to make a few demo boards for like the Kickstarter video. So this module is going to be able to be mounted on a few different boards. So today I'm just going to be building a Cherry MX, like my keyboard. It's going to have 8 keys on it. And what's cool about this module is that it's got like the regulator and it's got the SAMD and everything on here. And it's really easy to solder. That's the biggest benefit. So people that are worried about soldering really small pin packages, they'll be able to just put this on and like the bootloader will be on it and everything. And then you basically can make your own custom circuit boards really easily. So right now I'm in Fusion, which I don't use very often, I'll be honest, so I'm trying to use it more. And what I'm doing is just building what the PCB is going to look like so that I can import the drawing into KiCad. So we'll be doing that once I get this going. And hopefully I won't be in Fusion for too long because it's going to be not that great. Nice. You got your board? Awesome. Seems like everyone should be getting them. If they haven't gotten them already, hopefully this week. They've all been shipped. Oh yeah, you just have the kit. Yeah, that's right. Just gotta source the LEDs. There's lots of places you can get them, but depending on how. So the easiest way is to get them from Adafruit, but they're really expensive from Adafruit. You need 4 million. So from Adafruit, I think they're around 85 cents an LED, which is insane. It makes just the LED board for the Pixo something like $250 or something like that. So I would look on Alibaba or AliExpress. Alibaba, you could probably find the best deals, but you have to actually talk to someone. But that's how I get most of my components. Hey, Steven. neural network chip on the 101. What do you mean? Is there an Arduino with a built-in neural network? I don't keep too up to date on this stuff. Oh, the Quark. I don't have a lot of experience with it, but if that's what it's designed to do, it's probably awesome, but it's also probably has a bit of a learning curve. So on the software side of things, I'm sure there's some stuff to learn there, but yeah, I don't know. If you're planning on doing something with a neural network that's specific to that application, I'm sure the hardware is optimized to work in a specific pattern, and it's probably going to be optimized for a specific like learning algorithm. So I don't know too much about it, but that would be my guess. It's kind of like the Arduino can only run one step at a time. So if you're training, so I imagine that you could tell this chip to do some command, and then it will be able to do a whole bunch of stuff at the same time. If it's got, as you say, 128 nodes or whatever, it's probably able to like simultaneously modify weights and things like that within the network. So they probably implement some type of hardware thing into their code that makes it optimized for neural networks. Okay. So the Cherry MX keys, I have them somewhere. Hey, how's it going? Good luck with the LED curtain. That actually sounds really cool. Alright. See you later. Yeah, it would be cool to have a neural network shield for the Arduino. I thought about doing something like that, but it's not necessarily a shield, but like a board where you just have inputs and outputs. But it gets kind of complicated, but I thought it'd be cool to have something that's like um, something that you just give it inputs and you give it outputs to train, and then it automatically trains it if you have like a switch on train mode. So you give the inputs and the outputs, and then when you switch it to just output mode, then it would like do the outputs on its own, which is entirely possible and free idea if someone wants to do that. It's pretty cool. So, got some switches on this little board that I've been working on for a long time that I'm just using as measuring to where I'm going to mount them. Yeah, Raspberry Pi is good at that stuff. It's got a bit more processing power, but the downside is it doesn't have analog inputs, and so therefore if you're doing anything with a range of values such as any sensor or anything that's analog, then the Raspberry Pi is going to fall short there without having extra hardware. So what I normally do is I'll put like a small circle or something on the board. So say I want to put a switch here. I'll put a small circle there because when I export this DXF, it's going to put a small circle there in my KiCad, and I can align whatever component I want to that small circle if it's aligned in the center. So if I'm going to be putting a bunch of buttons, I'll put circles where the buttons are going to go. And by buttons I mean Cherry MX switches. And it'll be easier to place them in alignment after when I'm building the board. Now Cherry MX is just the type of switch. Some keyboards have them. They make this. They feel nice to type on. People who have mechanical keyboards, those have Cherry switches in them, or at least MX. I don't know if that's like a name brand or whatever. But I'm trying to decide. So again, I don't use this too often. The Cherry MX board is just going to be like a board with 8 buttons on it as a demo for one of the boards I'm working on. I see. Yeah, I figured it was a brand name, but I don't know if the new, I guess the new keys, there's like Kali or something like that. There's a bunch of companies that make them. I don't know if that company actually makes them. I know they make key caps. Alright, what am I doing here? I'm just going to search DigiKey for a data sheet that will give me some dimensions. I can use some rough dimensions. So that I can place this where I want it to go. This one's just going to be all, well, anyone can put whatever they want in, but this board is to demo this little module I'm making. So if you wanted to put a whole bunch of different switches in, you can. I'll probably put these blues or maybe browns in. $15.5. Do some paper math here. 8, and 10. Hey Brian, how's it going? So I went to Master University for automotive and vehicle technology. So I got a bachelor's in automotive and vehicle technology, and then I did my master's in mechanical engineering, which was mostly developing an electronic sensor and doing neural network stuff on an engine, an internal combustion engine. Hello, Elganak. Sorry, I don't speak Spanish. Okay. No, sorry, only English. Let's see. Nice, yeah. So mechatronics is the kind of the all-around best thing if you're just trying to get into electrical and mechanical. And I did I did TAing for some mechatronics classes. What are you working on at work, Brian? Something cool? Yeah, I thought so. Building. Okay. I haven't had much VR experience. Need to pick up like something, but I'm indecisive as to what to get. So I just grabbed this tin. I have a whole bunch of these plastic threading screws. Actually, those are machine screws. But I use these in a lot of projects, so I always have them on hand. And it's normally how I like mount my circuit boards to my 3D printed things. So I want to make sure that the screws I'm going to use, the heads are going to fit on the board and they're not going to be in the way. Yeah, that's the thing, like I don't even know. So I'd have, like I wouldn't have the room to set up a huge area for it, but I think it'd be cool to just, I mean I don't game that often anymore, but it seems like a cool thing to have. Actually, I always see this, I think it's the Vive that, I think I follow a guy on Instagram or something, and he does like drawings in 3D, like little animations in 3D, and he does like a whole bunch of them every day. And they're really cool. I think it'd be kind of fun to play around with, because I like drawing and animating as well. And the fact that you can do it like in a 3D space and draw something, that kind of like seems really cool to me. Okay, so these are 3mm heads. And we'll throw in a construction box just to see how they're going to fit. Did everything just move there? What? These are constrained. I see. Wow. Fusion, you're not what I'm used to. Where is this constraint coming from? Each circle is going to be a switch, yeah. So that's the center. And it's just going to give me like a locating point in KiCad. And they might not be perfectly spaced for what Cherry MXs are supposed to be, but I've got like my keyboard for reference and this thing, and it's not going to be, well, it should be basically what it should be. Okay. I'm going to do that for all of them. It doesn't really matter what the diameter is. And I will throw the dimensions for the base of this that I'm building now. I can print out a PDF or something if you want this after, when I get it all done. Yeah, Brian, I don't know if you're here before, but I'm building this small module and I'm doing like a Kickstarter for it, so I'm just making a few demo boards so that I can make a video on how you can use this. So I've got like an Arduino board, breakout, and this one, and then yeah, that's the end goal, is just to have a little keypad that will have this on it and kind of display this and show how easy it is to make. Hey Dave, you just ordered some Cherry MX switches? I don't like how Fusion orients the, like how it decides what's in control of what's constraining what, basically. Yeah, it's fun to make your own boards with them because you can basically do anything. I'm like, there's so many different kinds of keyboard layouts that there's like, I think I'm on a subreddit for mechanical keyboards, and there's like, people have these little tiny keyboards that they, I don't know, use for something. I don't think I could use it, but it's kind of cool. They like carry them around with them. Hey Simon, a little bit of both. I will search on Google. I will always try to do the least amount of work possible. So if someone has made a good footprint already, I will obviously use that. I mean, if it's available on KiCad. And if not, then I will make my own. It doesn't take too long. It's just kind of an extra step in the building process. But a lot of the time I find myself making my own because I'm using weird packages, or I want to change it a little bit so that it fits what I'm doing. I forgot how long everything takes when I'm streaming, but that's fine. That's the purpose of this. The Pro Micro, that has does that have the 32U4 on it? Or does that still have the 328? Okay, yeah. Yeah, the native USB is nice to have. It's kind of like, that's why I use the SAMD for everything now. Oh yeah, yeah. I think I saw your video on that. Those like 1 to 9, or the hex keypad. funny doing Fusion, learning Fusion on stream is probably not the best way to do it, but it's fine. I got, for the longest time I was like using CATIA, but I don't have that option anymore, so I had a license with my school, and I was building stuff for them, so whatever, it was fine. And I worked at Honda for a bit, and they use CATIA, so I was like, it takes me like seconds to do something that'll take me 10 minutes in Fusion. So, but Fusion's good. It's just, it's free. It's one of the main things. But I gotta learn all its quirks, just like CATIA's horrible things. Okay, so this needs to be a bit wider, I think. Or I can put the screw mounts somewhere else. Too many messages. What is there, like some slow chat thing on? Turn that off. Okay. So they're more centered, but that's fine. Let's see how it looks. So that's the head of the screws that I'm probably going to use. And then Cherry MX. It's about 15.5, so if we go 16. That'll be fine because they overhang a bit. So we'll put a hole here. I don't know any of the shortcuts. Not construction. I'll mirror that. Okay. Mirror these again. Nope. Let me see if I can turn that off. slow mode isn't on. That's weird. Don't know. How's the delay? Because I'm on the low latency. I know there's like 3 settings on YouTube. And I was on normal last time and the delay was crazy. Yeah, that'll be fine. Okay. So I'm pretty excited for this little SAMD module thing that I'm building. I haven't released too much info on it yet, and obviously there's like quite a few boards out there that do this kind of thing, but I think this will be great for prototyping, and like I know I'll be using it a lot, so that normally makes me feel like other people will find it useful. Basically not having to like keep prototyping the SAMD board onto every single board that you make when you're just trying to test something out. Should be the best part of it. Okay, so that's the PCB, I guess. Kind of an interesting shape. That's the point, is that people can make their own custom circuit boards and shapes and then easily solder on the Arduino onto it. So, something I haven't done in this before is... it's in the wrong folder. Project. Demo boards. Okay, create new drawing. Let's see here. Oh, is it going to do the whole thing? Alright, let's see. Just want the face. Millimeters. We'll see what happens. Hopefully I can export this as a DXF. That's all I want. Okay. Seems like that might work. So, output. Drawing. I don't know if we can use a drawing. Can Fusion export as DXF? Okay. You can export sketches as DXF. Let's see. Nice. And where are we putting this? So my laptop went to sleep. All my files are on my laptop. So I'm working on KiCad on my computer. But the files are on the laptop. Which can get a little annoying at times, but it's much nicer working on my computer. Demo boards, board, PCB. Alright, let's see if this loads up properly into KiCad. So I haven't actually put the schematics into the board yet. But we'll do that after. These are just the ground planes, which can be any shape. Import DXF file. Let's see what happens. Thought it might do that. Okay. That's alright. It also took the construction lines, but I'll just delete them manually. Okay, so that's the board in KiCad, which is pretty cool. That's how I do basically all my boards, because then they come out perfect to what I 3D print or have machined. So now I can use that to design some type of housing. I also like to put the edge of the board right at a, somewhere like here. But it's not absolutely necessary because you can set the coordinates in KiCad to whatever you want. So that's the board. So let's start throwing some schematics in. Now here I have like the reference module, but I'm just going to be pulling stuff off of this. I'll import the real one. So what kind of projects is everyone working on? Anything interesting they want to share? Right now I'm just adding a few libraries that I need. Don't need that one. Don't need that. Oh, maybe I'll throw some LEDs on this too, because why not? Got the pins. Yeah, if I had more power, like when I had all of them done, all of the Pixos, I thought it would have been really cool to have like 10 of them running, displaying something together, but I think that would have taken too long, and I don't have the the power supplies to do that, and I just wanted to get them shipped out. Let's see, do I have the Cherry MX footprints already? So many libraries, I need to organize this. Yeah, they're incredibly tiny. The supplier I was working with was actually experimenting with a new design that only has, so that design has 8 pins, and I don't know if you saw in the video that my friend who did the pick and place had issues with the 2 middle pins contacting that like other pins, like they were bridging underneath the boards. It was almost impossible to tell which ones were bridged, and if the board was shorted, then it was again impossible to tell which LED was shorted because none of them worked. So that's why I have a few boards that are full of LEDs but don't work, and they take, like, you have to manually test each LED. It's a pain. But anyways, the manufacturer is actually working on a 6-pin version that doesn't have those extra 2 pins. But the solution that obviously worked out well was just removing those pins from the board, from the layout. Right now I'm looking for the Cherry MX library I know I have. Save this. I will open a different project, because I know I use them. I have this small little gaming device that I've been wanting to finish for a long time. It's got like a little OLED 2 buttons and an accelerometer, and basically you play games by like using the 2 buttons, and yeah, it's got a little battery in there. And it's supposed to last a really long time. Kind of like a Arduboy, but I haven't finished it, and it just every so often I pick it up and make a game for it or something, but it's not at the point that I want it to be at. There it is. Okay. Where are these? Keyboard. Oh, that's the footprint. Okay. That's right, they're just buttons. Completely forgot. There's the footprint for the module. As you can see, this is kind of like a sneak preview of what it's going to be. And hopefully I can get people to make them for Eagle and whatever other software people use. And it's really easy to connect your USB device. So this is all one module. And then you've got these pinouts, I2C, and built in on board is the regulator and everything like that. So basically you should be able to do anything with it, and it'll be like ready to go, pre-soldered, pre-bootloader, all that stuff. Alright. So need some buttons. Switch. We get moving on this. We gotta get this thing done. This is taking way too long. It's already been an hour. Should only take an hour to build a custom board using this module. But of course, everything takes longer. Okay. Speed things up, so we'll pull some parts from another design. Hey AP Tech, hey Daniel. I'm designing, yeah, it's going to be like an 8-button Cherry MX board. This is what the PCB will look like. And it's meant to just show off this module that I'm working on the Kickstarter for right now, which means I need some demo boards to show how they work. So this is going to be one of the demo boards. And what I'm doing right now is just doing the schematics. Yeah, for macros, for anything, it'll just emulate a keyboard, so you can just have extra keys. Do whatever you want. Program them to do anything you want. Just going to steal some components from another board for whatever reason. So it's just going to be a quick project that isn't going to be like a product. This is just to show off the module. So it's just going to be 3D printed housing. Hey, how's it going? How's it in Norway? It's pretty warm. Yeah, so the video will probably be for the module, and then I'll show how to like build all 3 of these things and how it takes almost no time at all, which is the point of it, kind of. I have no idea why my switches have gone missing. No worries. Thank you. For whatever reason, my switches library has disappeared. maybe spark one. Okay, we're just going to use these as switches for now. I don't know what's going on with KiCad. Switch 1. This is KiCad. This is for designing circuit boards. I have 8 of these switches. And to save on components, since we have 8 pins available, we'll just do pull-up resistors, internal pull-ups, since I don't feel like putting resistors on, and also because why not? We'll just ground the other side. And they'll all be on their own pins, so we can set interrupts instead of like putting multiple buttons on each pin, since we got so many pins available. Just do it that way. Just make sure we don't put 2 pins on the same interrupt. So we're just connecting the buttons to each pin. I don't know why I'm copying them. And they're just named the exact same as what the pin is on the board, just for simplicity's sake. You mean via USB to power it? I'm going to power it through the USB, yeah. But the module has a regulator on board. Oh yeah, it's going to emulate a keyboard. And yes, I know these are, oh, that's ugly. It sounds familiar, but I can't picture it. It sounds crazy. I know there's like keyboards that well, like for playing music, they do analog, right? So it's not unheard of. And right now, you can tell we're just kind of rushing through this to get it done. Well, these don't need to be connected, but I'm just going to throw them on anyways. So we need to get this board done. What is their reasoning for doing analog, like a fully analog keyboard? It sounds really cool. I could see it being good for certain gaming aspects, but for typing in that, I'm not sure how great that would be. It's definitely a cool concept. Now there's, yeah, that's definitely a good use case for that. Or even like passwords that are like case sensitive, or you could do passwords that like you press harder on certain words. I mean, it'd be annoying as hell if you ever got it wrong. Alright, let's throw some. Should we put NeoPixels on? Or the APA 102s? But I have some of those. They're a lot smaller. Harder to solder on. There's some SK 6812s here that aren't being used for anything. Yeah, it's got the spot for the LED, but I think I'll put, you'll see once all these are connected together, we'll move over to the PCB design mode, and we'll place all the components, and then we'll wire them together that way. Yeah, I think I want to put some type of RGB on it, but I don't know if we need 8. I guess I could. Yeah, I'll throw the APAs on since they're not as hard to solder now with that better layout I made. That's the only concern. But it can be easily done with solder paste. And it's only 8, so they're not going to be drawing too much current. The SAMD is definitely what I use for everything, and that's what this module is, and that's the reason I'm making it. ESP32 is like, it's obviously super useful, and it's great that it's can easily handle Bluetooth and Wi-Fi. The only thing is I like a lot of the projects I do need to be low power, and as soon as you plug the ESP32 in, it instantly draws like 200 milliamps for a few seconds, I'm pretty sure. Something like that, I don't know. I could be wrong. And yeah, so the SAMD, I mean, uses barely any power at all, but it's still very quick. It's fast in terms of microcontrollers. It's got basically everything you need. Yeah, and it does get hot, and I mean, it's super powerful, but if you need low power and you don't want to be drawing so much current, then that's just the way to go, is to use one of these. And that is one of the main selling points. I mean, if you can stick this on something and you want to make a custom robot, you can stick it on as the brain, no problem, really quick. Something that wants to be like low power, like sensors and all that kind of stuff, or like little gaming devices that are always on. ESP is not so great for that. So you got to kind of, you know, it's not really a favoritism thing, but for the most part, I don't always need IoT. Per chip, I think it's like $3 to $4 for the chip itself. So yeah, there's another factor. It's like the ESP32 can be had for like what, $5 now? Yeah, I've heard some people talking about the 51 series. I haven't looked into it too much. I kind of get stuck on more on building projects like that demonstrate something than like looking into what's new out there in terms of microcontrollers. I'm really interested in when things come out, but it seems like there's a lot of things out there that it's easier to stick to something you know and then build the thing you want to build around that than to like try something new that might have a few extra features, but that sounds really cool. I need to check those out. Hey, thanks. That's awesome. Thanks for your donation. Really appreciate it. So I kind of got hung up. What am I doing? Oh yeah. So yes, you said the SK6812s. Yeah, they definitely be cheaper. The thing is, I have 5050s. I don't have the 3535s. But I also do have, I still have a lot of APA 102s hanging around. And really this board's just to demonstrate this microcontroller, so I'll probably use those because they're so tiny and I can fit them under the Cherry MX keys pretty easily. And they don't really have to be perfect, but they'll add some cool lighting effect and that'll look good on camera, and that's basically what they're for. Alright, so we got the switches, we'll throw in the APAs. "120 megahertz is pretty incredible." I'm going to put 8 LEDs on. I think they can draw about 20 milliamps each at 5 volts. So should be fine for the USB. And we'll just put these in a row. Connect them all together. course, I wouldn't be running these at full brightness anyways, so you know they consume a lot less. I noticed some people talking about the APA 102 being warm even when they're off, and actually I did notice that on boards. I didn't notice it at first because I was always driving some type of some type of display, so I couldn't tell. But I haven't really done a lot of testing into it, but it's pretty interesting that if they're getting warm just being off, they're obviously consuming some power. Yeah, they're warm when they're off. Yeah. Yeah, I didn't realize that until after, so I wonder what they're, I don't know if I checked the off current. Yeah, nice warm. It's pretty crazy though, like, I think there's definitely room for improvement for them, but still, they're pretty an unbelievable thing. Like, part of the reason why I did the Pixo was because I wanted them to become more known and become as cheap as the WS2812s or the SKs. Now, I can't remember if I can run these on 3.3. Test them out. Oh yeah, yeah. I found even the WS2812s, they pull about a milliamp when they're off, but they're a lot bigger, so I guess they can dissipate the heat better into the board. But yeah, that would make sense. So since I can't remember if these can be run at 3.3 volts, and I don't want to check right now because I'm just building this, I'm just going to add a jumper that will have both the 5 volts from the USB line and the 3.3 volts. Shouldn't have an issue with the logic being 3.3. No, should be fine because I've done it with an Adafruit board. Do this anyways. Throw a V-bus on there. And I can run them from either. And what pins should we use? Guess we don't really need the RX-TX or the I2C. Yeah, let's change these. And we know they're good for clock line. Alright, 20 minutes. Gotta finish this in 20 minutes. Don't actually have to. That's the goal though. But we'll also probably want to do some like cool graphics on the board. I've only ever used Premiere. It's really not that complicated once you start looking at other circuits and understanding what you need to do. If it's something you're interested in, you can totally figure it out. I don't know, that might be average. I'm not sure. Because that seems like a lot. 20 milliamps each off. So there's 256. No, because it would be drawing 5 amps. The Pixel would be driving 5 amps if it was off. But it doesn't. Because I don't think it does. For most of the, I think when it's fully lit up at the brightness that I have set at, then it only draws about 3 amps. Oh no, it'd be 500 milliamps, sorry. Bad math. It's 11:42 a.m. Well, it would be 5 amps. No audio. No, it's working. We had problems in the beginning, but it's here now. Okay, is there anything else I need to put on this board? I got the USB, got 8 LEDs, which is probably unnecessary, but whatever. 8 buttons. Buttons. We got the module. And we got power. Yeah, simple enough. So what we do is we have to assign each one of these footprints. So we click this button, annotate things, assigns them all values on the board like LED 1, LED 2, that kind of thing. And then we have to give them all footprints. So a couple of them have them. Those are all called switch 1, which I don't want. Some things just take way too long. What's cool about KiCad, and it might be the same for other programs, but you can actually open all of these files in a text editor and change them that way. So like if I wanted to, I just changed all those, they all said SW1, I just changed them from SW1 to SW8. But I could open that in like Notepad++ and done it a different way, or made some like Python script to do that, which is cool. So I don't think the keyboards, the Cherry MX switches are available in here just yet. I have to add them. Yeah, no keyboard. So what that means is, it's kind of annoying, but you have to go into the board view, and you have to add the library. So we'll add another library. Called Cherry MX. This is KiCad. KiCad. Some people call it KiCad, but they're wrong. It's KiCad. So I gotta find this. Keyboard, there we go. What I'll do is add that location, which is going to be a network location. That's fine because I'm working on my laptop. And because I added a new library, unfortunately, you have to close the entire program. Don't ask me why. I don't know. So now the keyboard library should show up. And there it is, Cherry MX. So we got all our switches. We can look at what they look like. We can find the one we want. Let's see, these all have the same, these are all the same, but see the outline is getting bigger because that's actually the size of the key cap, sorry. So there's the space bar, see how it's much bigger. And there's some other things in here too. But we're just going to do the standard 1U, pretty sure. What plate is. So just throw those on. Yeah, I make my, you mean component libraries? Yeah, I make my own libraries all the time. Can't remember what the last one was. The little power regulator on here. probably won't focus, but I couldn't find one for that, so I had to make that. I made my own APA 102 library. Well, footprints. They're no footprints, not like whole libraries, but see this idle hands lib, which is basically a mess, but it's just full of like random things that I either couldn't find or I modified. Here's the logo for my company. And it also just like keeps things that are used a lot or used once. It's built up between me and some other people that used it. There's the module that we're going to be using. So we'll put that on. Was it for like an SD card holder? So here's the new APA 102. Here's the old one. Quite a bit different. This one's way better though. I find that KiCad makes it really easy to make your own libraries and footprints. I really didn't like the process that Eagle had. Some people say it's better, but I think this one's great, like how you can just kind of assign anything to anything. So like, for example, for whatever reason I couldn't find my push button library things, which is some issue somewhere. Probably because I'm working on my computer and the files are on my laptop, something weird's happening. Anyways, I can just take these pin headers and pretend they're buttons, which is awesome. Because they're just 2 pins, so pin 1 and 2. So that's what these Cherry MX buttons have, just a 1 and a 2. So like those are just going to align to those. And because they're just switches, and we're just grounding them, it doesn't really matter. So what is J10? Oh yeah. Wonder if I have jumper for that. I don't know what that would be called. Hey Wiz. I'm good. How you doing? Yeah, it'll be on my YouTube, so you'll be able to watch it. Thanks for coming by, though. I wonder if there's jumpers anywhere. Next to the USB. I guess this is a good time. So I'm sure there is one that exists somewhere for jumpers in KiCad, but I can show you how to make a footprint real quick. I'll just take this 2-pin jumper and I will turn it into a 3-pin jumper. Cherry MX board is basically so Cherry MX switches are the ones using like mechanical keyboards, and this is just going to have 8 buttons on it, so I can program it to do different macros and things like that. But the idea is that I'm going to be showing off this module that I'm making, and the point of it is to show off how easy it is to make boards for the module and how you can solder it on. And this is going to be my next Kickstarter, actually. Spoilers. And yeah, so that's what we're doing. So I just chose this as a jumper, and then I'll show you how to modify it so it's going to actually work with what we're doing. Okay, so we'll save this, and you'll see, so these all have footprints now. So if we go over to the board view, forgot one thing. In KiCad, there's this net button which kind of generates a file where all the connections go and what footprints they're using. So every time you change something here, you have to generate the net file again, which takes half a second. And then when you go back in here, you have to read the net file, and it's going to import all of the components. So it just said error. The error was that my jumper only had 2 pins in the footprint, but in my schematic it's got 3 pins. No big deal, we're going to fix that. So here's all the components. And what I like to do is spread them all out. Go into component mode. You actually have to go back into this older style, which is horrible. And global spread in place, spread out all footprints. Let me go back, and I hope this fits. Yes, it does. Okay, we're good. So there's the module. You can see how easy it is. This is the USB section, and then we got all the pinouts and the regulator and all that. So the module is going to be this on the board. That way. And then we got these, which hopefully, yeah, so see how their center location is there? I can take these center locations so it's some arbitrary number, and we can assign it to this center location. Or you can just do it manually, which works like 90% of the time. So we'll place these down. Yeah, it's not exactly going there. Sure, there's better ways to align everything, but do it this way. Center X. What's up, Nicholas? Well, there we go. Dead center. And we'll do that for the rest of them. Hopefully they're not too close together, or we'll be playing around with them here. So what I'm just doing is copying that center for the X, putting it here, then doing it again for the Y. And I think they're overlapping, but fairly certain, let me see, that my keys are okay. I think it'll be fine. Worst case scenario is I'll make my own keycaps. Let's see. $18.7. I just popped off one of my keycaps to measure it. We've got a pretty solid 18. Thanks. Thanks for coming out. See you, Steven. I might move these around a little bit. No worries. That's I appreciate it. Anyways, that's great. So I think I'm going to move these a little bit, just so they fit better. So what I'm not going to do is go back to the Fusion. Guess I could. Yeah, this might be easier actually. So what I'm going to do is take this sketch, somehow open it. It's basically like a mini keyboard, mechanical keys, mini mechanical keyboard. That'll have 8 keys on it that you can run macros. The idea is to show off this new module I'm making, which I will tell you more about soon in a video. So I'm basically making it to show off this module. Let me see, let me edit this sketch. I know how. There we go. So instead of 18, let's go 9 here. Well, thanks for subscribing. And which should have been 9 anyways. So 9.25, and we'll go 2.5. For some reason, my subscriber notifications are not coming up. Cool. So let's play it a little bit more safe. 9.5, 19. Which means we'll go a little bit wider, which I think screws everything up, but we'll see. No, that worked. That was okay. That's still 25. Alright, and this spacing here, 9.5. Which means I'm a little bit taller. Not that tall. Oh, I see. Okay, so much better, more room, and they should fit better. So I'm just going to export that again. It's not the most amazingly shaped thing, but yeah, it does kind of look like a piano. But I think it'll look cool. We'll add some like cool graphic on it or something. Got to tweet out. The stream is going. Alright. So what do I do? Oh yeah. Save as DXF. Resave it. Yes, it replaces it. Go back into KiCad. One cool thing I can do is if you go back into this mode, you can tell it to only select board outline. So don't include any of these. Just include board outline layer. Move it out here. And delete it. Now let's put the new one back in. So everything should be a little bit wider. I'm just going to put it out here for now. Get rid of these extra things. Because for some reason Fusion puts the construction lines in the DXF, which is fine. In this case it's fine. Some boards I could see it being awful. All pianos are odd looking, don't you think? Okay. We'll start positioning these once again. Centering them over the holes. Yeah, that's better. I mean, it's a tight gap, but I think that's good. Close enough. And I just realized I can do the same Y for all, so that'll save me some button clicks. Do this Y. Perfect. Nice little overhang on each side. We'll cram some LEDs in there. Might be tight. Okay. Another fun thing to do, but I don't have the keys actually imported, is to go to the 3D view. It just kind of gives you a better idea of what it's going to look like. So, nothing special, but kind of cool. We'll take the Y, because I can do it for all four. Let's see. 1, 2, 4, and now they're a big mess. 1, 2. Did you just ask me to dab? This is a no dab zone. Okay, are these going to be a problem? Maybe. I think it'll be okay. Okay, and then we'll throw the USB somewhere up here. It's a little close, so maybe we'll move it back. We'll see. Move this down a little. And now, oh yes. So let's change this jumper to what it's supposed to be. And what I'm just going to do is edit the footprint. Move that over. Take this one, make a second one, call it 3. Take 3 and minus the position. This, this, and that. Actually, I think I want to move these a little closer. Just that's how I feel. They should be closer. So what this is going to do is going to allow me to pick which power source I want to run the LEDs on, 5 volts or 3.3 volts. And because this is just somewhat of a demo board and a test, we'll see what is the best thing to do. So now instead of saving, it is, yeah, it is really satisfying. And it's like, it's that's why I love pre-planning so much. Because like, it goes from this to actually seeing them go together. So you export and goes into the library, jumper SMD. You call it three-way. Three-way jumper SMD. And because I know this name, I just saved it as its own file. So I can go back into the board, go here, and change footprints, and now I know it's called three-way jumper SMD. So I think I saved it to the wrong spot. Okay, let me go back. Worthy of a dab. Dab free zone. And then we'll change this to, we'll do this again. Okay, it worked that time. So now we have this jumper. So as you can see, one side's VUSB, the other side is nothing. I think if we read the net list again. There we go. 3.3 volts. So we'll be able to put this on the board and select which voltage we want. We'll hide it somewhere over here. Might make it a little bit bigger actually too. But no, it's too dangerous. Throw stuff everywhere. Okay. And now these LEDs, which are not labeled. Great. We know this is the first one. Because it goes up to the microcontroller. So where do we want to put these? Is there enough? There is enough room in front of them, but are they going to be blinding? Let's put them behind. Put them back here. Does that sound like a good idea? So we'll go 1, 2. These are the APA, this one? These are the APA 102 LEDs. These are tiny. 3. 4. I will do this by hand. So, because I'm only probably making one of them, I'll just do everything by hand. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. I don't know how well they'll light up, but they're there to do something if I want them to. I'm going to change this a little bit just because I want it a little bit wider. Let's go 5 millimeters and 1. Oh yeah, it should be no problem. This is pretty much what I do daily. I haven't actually got too many boards manufactured. I normally just do them myself. But I'm going to start getting more things made. Okay. It's a little wider. Alright, that should be better. Just export as the same file. Can't save it. And then we change footprints. Bigger. Okay. So from here, I don't know, I'll put this somewhere. So that's pretty much it. So now I just need to run all the traces. And I like everything to be kind of neat and orderly. So as you can see, it's pin 13 goes here, 12 here, 11, but then I have 6. Where does 6 go? Right there, 4, 3. So sometimes I'll change stuff around. As I'm going. Now when you do weird board shapes, this kind of thing happens where stuff goes off the boards. It's kind of annoying, but I don't think there's a way to prevent it in KiCad. And I normally have shove on, which means it'll actually push traces out of the way. But sometimes that's more annoying. It really depends on what you're doing. See, now I put D11 here, but then D10 is going to intersect with it. So one thing I can do is I can either move this over here, or I can change which pin goes on here. And I'll show you, I'll just do the change so it's easier. So I'm going to switch D11 with D10, and then D5 with D11. No. D11 with D10, yes. We'll do that. Do it that way. Actually, so this is part of the challenge when you're building board, is you want kind of the most sensitive lines to have the most direct path and to be like the least interrupted, so like the least amount of vias and things like that. So I think maybe I'll run the LEDs, and then I'll run all the buttons. That'll be easier. And if you're trying to work fast, like I am, you're going to care less about really what you need to do. Like, what's the best way to do something? You just kind of do it. So I'll run power from all these. And normally you try not to do 90 degrees like that, but again, actually I was thinking about that the other day, but I really couldn't imagine how to do it. I think it'd be super cool. Oh, one other thing we should add. Yeah, I would love to be able to make a really properly optimized like generator, trace generator or whatever, auto router. But I'm not really even sure where to start on that. So I'm going to add a couple of capacitors. For the LEDs. Just 2 of them. The rule is, so if you have a trace, you try not, on signals, you try not to do 45 degrees because it'll cause like induction or whatever. Basically interference. It's like making a little antenna. So you try to keep things to 45s. Doesn't matter so much for the power lines, but signal lines and things that are changing, you don't want to affect other parts of the board. But when we're doing this kind of work, honestly, you can do whatever you want. You're really not going to hurt anything. But you know, if it's a clock signal and you're doing a whole bunch of 90s, you may mess up the clock signal somewhere. So I'm just going to put small 1 microfarad capacitors. Those are connected, and then we'll do the net again. Yeah, I think that's one way to do it. Also, because you're using a neural network, one interesting thing is you could take some really already optimized boards and use the traces as a training method. So like if you've already got a board made, so if I had a whole bunch of boards already made, it could take the name of the board, the way it's traced, and it's like its path basically, and use those to train for those traces on other boards. So that was one thing I was thinking about. Instead of actually like trying to figure out a path, you try to mimic previous paths by like using an input. So we need to add those capacitors. And we'll just do 0805 because yeah, definitely give it a go. It's something that would be really cool. I would love to not have to be able to route PCBs. It's just the auto routers are terrible. They're always bad. For this board, I could probably get away with it. But for others, no way. I'm going to put that over here. Yeah, or also even you could assign like priority. So your inputs could be like wire name, priority, distance, and something like that. And you would train a whole bunch of different things based on their priority. And then you would have to incorporate it on top of an already made auto router so that it could, instead of just like randomly trying all the paths, it could apply like a predictive measure to do certain traces first in a certain way. It's alright. yes, we're almost done, but we'll still got some more things to do. Yeah, that would be super cool. I mean, that in itself would be. I mean, I would just make my boards that way all the time, even if they weren't even like perfect, but they were all designed by a neural network. That would be so cool. So since these buttons are through hole, I can run the traces on the bottom layer since it's a two-layer board. There's honestly no real reason to not do two-layer boards anymore unless you're actually developing your own boards, which obviously some people do. See you, Nicholas. Thanks for coming by. Hey, Clark. Alright, we're going to go under with this just because I feel like it. Come back up right here. Actually, while I'm at it, I'm going to do all these grounds. So I like to, I think it's pretty standard practice to put a via for every surface mount ground so that it's going through into the other side. Now if you see what I'm doing here, for 8 LEDs, just imagine the pixel, which has 256 of these LEDs right beside each other. And you'll see why it's so ridiculous. Thank you. Hopefully it's helping some people out, learn some things. That's the idea. I don't like the way these are. I'm going to delete this. Change it a little bit. For no real reason other than I want to, and I think it'll just look better. Hello. What's it like in Mexico right now? Should have taken a break a long time ago, but let's just get this done. So we got the LEDs wired up. You can see the signal lines go around, come down here. Now we got grounds. And so we can connect these up. The USB. Push this over a little bit. Hey. Okay. I'm just going to hide these. Need to come up with a name for this board. Something. This is why I like to do graphics not inside of KiCad. Because to get the radius of this, I have to take the center point along X and go 1.5 over this. So that would be 6, 1, 2. So there's a 3 millimeter radius. That's just to let me know that I can put the screw in here and it's not going to touch the switch because the switch is over here. They kind of angle down, so the piece that is actually touching the PCB is this, and then it angles out a little bit to this wider area, and then it gets skinny again, as you can see. So that'll fit just fine. That screw will be fine there. That one will be fine there. This one will be okay. So we can route the buttons now. Now, let's see. What am I doing here? I don't know if I'm being lazy by not putting pull-up resistors. What does everyone think? I'm sure the internal pull-ups are fine. But do I want to do that? Let's see. Maybe I'll just put a bunch of resistors up here to pull up. No, I'm not going to be putting this thing to sleep, so it's not a big deal. If I was going to be putting it into low power mode, then I would put in external pull-up resistors or pull-down resistors. But it's always just going to be on, so it'll be fine. So what we're going to do is run these now, but on the bottom layer. That's right, we need to switch two of them. So switch 11, 10, and 5. Switch 11 with 10, 10 with 5. See, every time you make a change like that, you gotta read the net list because it'll switch it around. So that's 13, 12, 11, 10. And then we'll do switch 5 and 9. I like to do them one at a time because it can confuse your head a little bit. And yeah, you end up switching around a few times, but that's alright. 5, So we'll do 6 here. No. 6, 5, 4. All right. Comfy button. Six and 5. And 4 should be good. So it really doesn't matter what we have them here, on here, or in the program, because when we write the Arduino program, we can just like say, button 1 is pin 13, that kind of thing. So we're going 13, 12, 11, 10, 9, 6, 5, 4. No idea what that noise is. Sounds like they're cleaning the street. Ooh. Now you can see that they're very ugly, but depending on how OCD you are, you just need to put them in. When there's too much room, it's harder to make decisions, honestly, so you just gotta do it. You need to see what that noise is. Some construction out there. Yeah, I guess I gotta tidy these up a little bit, but really there's no reason. So you can see the green ones are on the bottom layer. So to show you that, you can see the LEDs here on the top layer. All the button signals are on the bottom layer. Oh, I see the names. Yeah. Sorry, I didn't know what you were talking about at first. So I think that's pretty much everything connected. And yeah, we could come up with a logo or something. Or just, well, I gotta throw my logo on there. That's what I do. My boards. That's, didn't like that. So let's see. That. Yeah, so it's the SAMD21G, and it's for this module that I'm making. So this board only exists because I want to demo this module that I've designed. So that's what this is. This is the solder pattern, and it's designed to be like simpler for people to learn surface mount soldering, that kind of thing. Buttonzilla. Okay, so logos, let's see. So I have my SH logo. I had to come up with a logo for this too. So maybe that's what should be on here. I have that, which is the mask. Let's see. Yeah, we're brainstorming. That's how it works. Of course, I haven't done my part yet because I'm focusing, but yeah, something doesn't need to be too crazy of a name. I'm going to rotate this because 3.3 volts. Yeah, you can do internal pull-ups on this MD. I think the thing I was worried about with this was that it's normally in low power state, and just made sense to me to put pull-up resistors externally, but I don't see why this should be a problem. How about Modzilla instead of Buttonzilla for the module? And then I'll get a logo of Godzilla and I'll put it on this. How about that? Let's see. I'll show you the process of making a logo for, yeah, you know. Oh no, copyright material. Let's see here. Classic. Okay, there's a good one. Even though it's a toy, it should look pretty cool. So, let's open up Photoshop. And what do we need here? No, I'm gonna do like 1600 pixels an inch. And the size, let's say centimeters. How big will this logo be? Let's see. So we got, oh, it's tiny. Don't have a lot of room for a logo. I guess we could put it on the back. Let's see. 5 millimeters? That's way too small, isn't it? Am I reading that wrong? Oh, 12 millimeters. Okay. Yeah, that'll be good. So we'll do 13. Yeah, I'll do 13 by 13. 13 by 15. Okay, so we'll copy this here. Fire. Okay, let's get some fire then. That's good. Watch that. Cartoon flame thrower. No, 13 millimeters. I guess I could just draw my own flames. Let's see. That. 1.3 centimeters. Did I? No, it's 1.3. We're good. We'll take this. What's going on here? Yeah, no problem. Thanks for looking at it anyways. What do we think? Is that looking good? We're getting a little off topic here, but it's all part of the process. Let's okay, so we got that, we got this. Actually want to enlarge this a bit, which is fine because it's all going to be much smaller anyways. Thinking just that, just like that. Enlarge and thin out the flame. Something like that. It's gonna lose quality quite a bit, you'll see, so I think it's kind of funny to just have it not so great. Okay. Hopefully we'll still have some details. It might show up like a tongue, yeah. We'll see. Let's just we'll go to grayscale. Flatten. Let's just see what it'll look like real quick. So 50% isn't going to work. How about that? Alright, we're just going to have it out here. We just got to get this logo on there. Get this board done. And we'll add some words. What else do we need? Oh yeah. We're actually still working on it, so it's here. It's pretty much done, but I'm just going to be putting a logo right here for Modzilla. So that's what we're doing right now. Which is, anyone coming into the stream right now is going to be kind of confused, but that's what's happening. Okay, let's just try this. And let's try a bunch of different things. Let's see how that works. So we'll save that as Modzilla desktop. We go here and click this button, which lets us import images. And export them as silkscreen. Modzilla. Actually, I think I had to. Let's see how that looks. I think I may have had to reverse it. I can never remember. Let's hope we just didn't crash KiCad. Because we might have. Okay, wait. I better save. I'm pretty sure I saved, but I should save right now. Yeah, it's a little bit too complex. It's not happy with this logo. Let me just Get rid of it. What is even happening right now? It's moving back and forth and I'm not touching it. We may have some issues here. Yeah. Well, I thought just because it's like a standard, like most of my logos are, I use like 1600 pixels per whatever, centimeter or whatever it uses. I guess I could just do the outline. But I figured since it was just a logo with the same amount, then yeah. Yeah, I could have simplified it in Photoshop. It's kind of funny, it's just an outline anyways. I really don't know what's happening. So I'm going to let it do its thing for a little bit, for a few minutes. I'm going to go grab a snack real quick, and maybe it'll like stabilize so I can delete it. 1 second. Oh, it's gone. KiCad's thinking. Let me just throw a giant BRB on there. Oh, it's back. KiCad is not happy right now. Yeah, it's like moving around. I tried to save, but I think I saved. Probably not. Probably didn't save. No, I'm just kidding. It wouldn't be that far back. There it is again. I will be back in 2 minutes. So yeah, weird things are happening. Let me look at the file. Godzilla's back. I also think part of the problem might be that I'm working over the network, which KiCad really isn't designed to do, but I'm doing that anyways. This has been a long stream. Okay, so there's a save at 115, so I'm not too concerned. Let's just I don't think there's anything I can do to KiCad to make it chill out. I'm just going to close that. Let's back this up. Throw a filter on there. Or what's the one? No. It's one where you just simplify the colors. Posture. Still running back there? No. Yes, close. Yep, those are all good. If the Godzilla's still here, I'll have to go into the file. There it is. It's working, I think, as I move it. Yeah, as soon as I tried to move it, it freaks out. So, yeah, I'm about to finish soon anyways, so look at this Godzilla on board, throw the name on. I have to delete this, close it, and I have to go into the file and physically remove it, I think. thanks for coming out. And I'll try and do this more often because I have a few more boards I gotta do. And yeah, it's fun. If I gotta do them anyways, might as well stream them. Hey, Oscar. Now I can see why. Let me close some of these files. Show you the Notepad++. So you can see why this is crashing. This is the Mozilla. One second. This is the Mozilla and it's huge. It's a lot of coordinates. Yeah. Yeah, he's freaking out at something outside. How long does this go on for? Can I collapse this? Yeah. I get by with Notepad++. That was in a terminal, maybe. I'm gonna just get rid of this whole thing. Okay, wait, let me see. How to not import silk screens? Absolutely. Actually, I've never had this happen. I've had some really complex ones before, but course, it would happen on stream, so. I've had things be really slow, but normally when I reopen them, they work fine. So I'm just playing around with some things. This is crazy that it won't open. I have the backup of it. You mean instead of KiCad they wrote their own app? Is that what you mean? Yeah. Okay, let's go on here. Let's get this sorted out. If it don't do anything, click it. And delete it. It's everything. What the heck just happened there? What the heck? I'm having some serious glitches right now. Oh, maybe if I take it out of OpenGL mode. There we go. Just left OpenGL mode or whatever. Yeah, and that let me do it. Okay, let's make this way simpler. So what I was gonna do was just do this. Yeah, just something like that. Thing is, I think it's because it had so many individual points. It doesn't need to be perfect. Like, we're literally just wasting time by trying to do something funny. There we go. Good enough. So let's try that again. Go back in here. So there shouldn't be a whole bunch of random things now. At least we know how to delete it. Alright, let me save this time. Yeah, it's the wrong way. Still not super happy about that. The program. I'm fine with it. Yeah, it's gonna turn out so horrible. On the actual silk. That's alright. This is all gonna be mashed together in here. So do I add the words or just leave it like that? Let's see here. So that is the board. Now I make it more minimalistic. Just find a more cartoon. The problem is you only got 2 colors, right? So you could actually just like fix the arm here. So I think I'm gonna call that for now. I might change that logo off stream before I order it, but I think that's a good demonstration of this board, and yeah, I don't think there's anything else left to do. Let me check the do this here. Check the DRC, so make sure there's nothing wrong with the rules and guidelines. So right here, it says there's a track near a via, which is right here. So this track is too close. Move that one. Move that one. And it's also saying, oh, and it's also not connected, which is the next thing I was going to check. So list unconnected, and saying this ground is for some reason. So we will add a via there. And we'll connect this. Yeah, I could do something like that. I might do that off camera so I can actually put time into the design a little bit. But that is the board. Let's check the DRC again. We're good. Nothing unconnected. So that means there's no unconnected pins. And yeah, that's it. That was a pretty good stream. Almost 4 hours, jeez. So thanks everyone for coming out and watching the Modzilla come to life. And yeah, if you enjoyed the stream, thanks for subscribing if you have. And if you want to support future projects, you could always become a patron if that's possible for you. If not, no worries. I want to produce as many projects for free as possible, these included. These will be out soon, and keep an eye out for this module. I'll keep everyone posted who is subscribed to the channel and follows me on social media and everything about when that is going to go live on Kickstarter, so you can get an early bird. But as you can see, I don't even have a completed module yet, so I'll be doing that this week, then getting these boards, making a video, and then doing a Kickstarter. So think I'm gonna head out. Thanks everyone for coming by, and I'll see you next time. See ya.